Hi, it's Jeff with Cribl. In this video, we're going to walk through configuring an AWS S3 object storage destination using Cribl Stream, Cribl's data processing engine. We'll focus on the setup of this in a Cribl Cloud account, Cribl's as-a-service offering, and the best way to take advantage of the suite of products. You can sign up today for a free 1 TB account with no credit card required. Just visit us at cribl.cloud. Note that some of these steps will also apply to an on-premise or customer-managed installation as well. And this process will also be very similar for other object storage destinations like Azure Blob and Google Cloud Storage. In this video, we'll be performing these steps. First, we'll need to prepare our AWS environment, which includes things like an S3 bucket and the appropriate permissions. Next, we'll configure the Cribl Stream S3 destination. And finally, we'll send some test data through a route and confirm data is making it to S3. Future videos will show how to do a replay of the sent data to re-ingest it later using Cribl Search to search the data without moving it, or how to use Lake, Cribl's managed data storage service offering that simplifies this whole process. A note before we start. If you want more information, make sure to check out our docs. There are some general and in-depth setup instructions as well as some troubleshooting tips. We also recommend the S3 Better Practices doc as well. You'll find detailed discussion about the best ways to configure and tune storage destinations, and we'll be using this guide for our setup in this exercise. Let's get started. Before we can configure our AWS storage, we need to determine how we will authenticate. There are two main options, using an AWS IAM role or using secret and key credentials. If we are using AWS workers, whether they're the Cribl hosted ones or our own, or using AWS components that allow for it, we can and should use role authentication. If we aren't able to, then secret and key authentication would be used instead. I'll be using my Cribl Cloud provided workers hosted in AWS. I'll click on my workspace name and then click Settings. What we're after is the ARN or Amazon identifier of our Cribl workers. We'll need to use this on the AWS side to give our workers trusted access to write data to S3. We'll click Trust on the left menu, then in a notepad or similar window, copy the worker ARN for later use. To set up the AWS side of things, you'll need access to services like IAM and S3. In many organizations, this is done by a separate team. We'll walk through the basic steps here, but note that your environment might have different policies and requirements to make this work. Navigate to the Identity and Access Management or IAM service. You can put IAM in the top search bar to find it. Once in IAM, select Policies from the left menu and click Create Policy on the upper right. We can leverage Cribl docs to get the policy needed to allow object reads and writes. See the Amazon S3 Better Practices doc for the section called Amazon S3 Permissions. We'll copy this policy for use. In the AWS console, select JSON from the policy editor line. Replace all of the text on the screen with the policy from the docs. We also need to replace the bucket name with our bucket name that we'll be using. My bucket is called jw-cribl-storage, and I've changed the placeholder in the text shown here. Take a look at the permissions being granted. Because we'll be asking Stream to write objects, we'll need to put or write level a permission to do so. Now click Next on the bottom right of the policy editor, fill in the policy name with a useful ID, and then click Create Policy at the bottom right. We're going to be using role-based access as our way to authenticate. Now that we have a policy created, we can create a role to attach it to so that the role can have these permissions. Click Roles on the left menu, then Create Role on the upper right. There are different ways to create IAM entities. For this example, pick Custom Trust Policy. Let's go back to the S3 doc. Using the sample policy from the page, we need to replace the ARN in the sample policy with the Cloud Worker ARN we captured in the beginning. Also, it's a best practice to use an external ID for security reasons. Back on the role page, I've edited the text with my Cloud Worker ARN, and I'm using the secret Goats of Cribl and have pasted it in. Click Next on the bottom right. Now we can add the policy we created a moment ago. Find it via the search box or looking through the list. You can select Customer Managed in the Filter by Type box for easier searching. Select the box next to the policy you created and click Next on the bottom right. We'll enter a role name. Confirm the trust policy and permissions look correct and click Create Role on the bottom right. You should see your role in the list. Click on the role name and copy the ARN for later use in Stream. And that's it for AWS permissions. Now we need to create the Stream destination route on the Cribl side. I'm logged into my Cribl Cloud account and am in Stream product interface. I'll click the group called Default to use my cloud AWS workers. To set up the S3 destination, click Data, then Destinations. We can type in S3 in the filter box and click the Amazon S3 tile. Then we'll click on the Add Destination button on the top right. Enter a friendly name for the output ID. Enter the S3 bucket name exactly like it shows in AWS. The data format can remain as JSON. There are options for raw or Parquet formats as well if you want to use those instead. And next I'll pick the region my bucket lives in AWS. For the key prefix, we can enter a static or dynamic option here if we want our folder structure in S3 to begin with something before our main partitioning scheme. You might use this if there will be other data in the bucket and you want to separate it. For this example, I'll be using the string stream. Now we need to input a partitioning expression. This is how the folder structure will be organized. We can enter static and dynamic values here. Most of the time we want to make sure we have at least a date and time to make retrieval and search easier and more efficient. I'll click on the Advanced Mode button to examine it further. A default expression is provided. It is a Java statement that means this. If we have an underscore time field in the event, then extract out the year, month, and day, and put slashes between them. If we don't have that field, then use the current time to get the extraction instead. I'm going to overwrite this to accomplish two additional things. First, I want to add in the hour as well. This will make retrieval even more efficient, especially for higher volume sources. Second, I want to also add another field that will identify the type of log in each folder. For example, if this is a firewall log, I'd like to have that called out in the structure. You might choose to use some of the fields you would use in your downstream analytics tools. If I were going to search these in my SIM by a field called X, then maybe organizing them that way here makes sense. You can use anything that makes sense for your environment. I'll use a dynamic field called source type that should be in my logs. I'll also have logic that assigns a value if one isn't found. Here's what the expression would look like. Before we go on, a quick note about cardinality, which is the amount of unique values you might have in your logs. For example, if we were to pick an expression that included the destination IP address from our firewall logs, that could be hundreds or even thousands of values. If we have 5 firewalls, then that number jumps to 500 or 5,000 or more in a time span. If we continue to add fields with our different possible values, our cardinality can get exponential. The impact is that we will increase the number of open files on the file system as we wait to write these to object storage. The long story short is this. We want to choose fields that do at least some categorization to help with retrieval, but not so many that we overload our workers. Check out the Better Practices doc for more detail and suggestions on this topic. Back to the config, we have a few more options. I'll leave compression on and I'm going to leave the file name prefix and suffix expressions as the default. You could customize these more if you would like. With this done, we can now move on to setting up authentication. Click Authentication on the left. Since I'm using AWS workers and roles, I'll make sure this is set to auto. If we were using keys and IDs, we would choose manual instead. Now we'll click Assume Role. This will be where we set up role-based authentication for S3. Slide the Enable slider to Yes at the top. For the ARN, we'll paste in the ARN value we copied from the AWS IAM console for our role. Here we also need to enter the external ID if we're using one. I am, so in mine goes. And that's all we'll configure to get this test up and going. But let's look at the Advanced Settings panel. We see a number of options that let us tweak file settings and timings. We can change these if needed if we encounter any issues. Click Save on the bottom right and then do a commit and deploy in the upper right for the changes to take effect. Once the workers reload, we can do a quick test by clicking on the destination, going to the Test tab, and clicking Run Test. We should see a successful message on the bottom. If not, we'll need to check the permissions, policies, and authentication, and be on the lookout for pesky typos or miscopied data. We can also check in S3 itself to see if the data arrived. Here's a quick view showing it has landed in the folder structure as we expect. Our last step is to use our S3 destination for our production data. You might do this for many reasons. Some of the most common ones include storing a full fidelity copy of the data for long-term storage and retrieval. Or, if you're going to drop some events and not send everything to your system of analysis or SIM, you might choose to send those to object storage instead. I'm back in my default worker group and have navigated to the routes page via routing, data routes. I've created a route that will send all of my firewall data to S3. It's in the first position because data is processed in the order seen here, and I want the S3 destination to be first. Routes always have 3 main components: the filter or source data, which tells Stream which data this route should operate on. Next is the pipeline, which tells Stream how to operate on it. And last is the output or destination, which tells Stream where to send it. My filter is using my data generator firewall logs as their source. My pipeline is set to pass-through, which means that data will be sent without any changes. This is the normal setting for a full fidelity copy scenario. And the output is my S3 destination that we just set up. I set up the route and then did a commit and deploy. Switching over to my S3 panel, we can see the data landing in S3 and is organized with the date, time, and the source type field. And that's it for this exercise. In just a few minutes, we've done the following: prepared our AWS S3 and IAM environments to receive the data, configured Cribl Stream with our S3 destination, and finally, we did a test and routed data to make sure everything was working. Future us might have a bit more work to do. Our next steps might be to tweak any destination settings as needed, or we might also want to try out using Cribl to do a data replay to bring the stored S3 data back into stream. We could even use Cribl Cloud search option to search the data directly. We'll cover the replay and search scenarios in other videos. But for now, we'll pat ourselves on the back for a job very well done. If you want to learn more, check out our documentation at docs.cribl.io. You might also want to try out our free sandboxes at sandbox.cribl.io. And join us at community.cribl.io to be part of the GOAT herd. And until next time, thank you so much for watching.